Hey there, fellow code wizards, I'm Mo. Today we are diving into some fundamental concepts of C Sharp. Whether you're a newbie or brushing up your skills, this video will help you understand some core concepts of C Sharp. So grab your favorite beverage and let's get started. Today we are going to talk about default values, conversions, call by value, call by reference, class method, and instance method. Let's kick off by talking about default values in C Sharp. You might wonder why default value of a string is null or why int defaults to 0. Here's a quick explanation. In digital world, everything can be simplified to 0 and 1. 0 signifies no voltage, while 1 represents approximately plus 5 voltage. It's a digital system, so there are no values between 0 and 1. Let me draw a CPU. In a CPU, there are numerous pins, and the motherboards send either 0 or 1 voltage to these pins. When it's 0, no energy is consumed, but when it's 1, energy is used. When a variable is created with default value, it aims to save energy. For instance, here we have int variable. Let me draw the memory structure. At bottom we have heap, and at top we have stack. The default value of our n variable is 0. So when the CPU tries to read this value, because it's 0, motherboard won't send any voltage power to CPU, so it wouldn't consume energy. Same story applies to the boolean. The default value is false. So it means when the motherboard sends the voltage to CPU, it's just 0, 0, 0. Similarly, when we have a string variable, initially it's null because it shouldn't consume any energy, and we don't know how much space is needed. So it's pointing to null, nowhere in the CPU. And that's why if you write something like s.length, because it's pointing to null, you would get a null exception error. Next, let's talk about conversions in C Sharp. There are different ways to convert data types: implicit, explicit, boxing and unboxing, casting. These concepts may sound confusing, but we will dive into them in the upcoming videos. For today, our focus will be on implicit and explicit conversion, which occur for value types at stack. Let's see the implicit and explicit conversion into code. Here we have implicit and explicit conversion sample code. In the implicit conversion, compiler knows how to convert one type to another type without losing any data, and it's completely safe. So that's why here, when I'm converting into long, there is no warning or anything because the compiler knows it's 4 byte is going to convert to 8 byte, and that's completely safe. There is no risk of losing any data. Now let's talk about explicit conversion. This requires you to explicitly instruct the compiler to convert the value, often using cast. This is necessary when there is a risk of data loss, such as converting long to an int. For instance, as you can see, if you try to convert long to int, the compiler will throw an error, as it cannot implicitly convert the long to int. It's a bigger value, and it is quite possible we see data loss here. So now we must use explicitly conversion. So far, we have only discussed the value type conversion, which occurs at the stack. Let me draw the memory structure. But what about conversion from value type to reference type? This involves a concept known as boxing and unboxing. In the next video, we will explore boxing and unboxing, which are crucial when converting between value types and a reference type. Now let's explore call by value and call by reference. These concepts are crucial when you pass variables to methods. As you can see in this sample code, we have a variable named number here, which I just printed. But in the modify number, I expect to change it to 20. But when it comes to the application, it is still 10. So what's happening? Let me draw the memory structure again here. At top, we have stack. And when we are creating this number variable, it's going to occupy space in the stack with a value of 10. In the next line, when we are calling modify number, we are passing this variable number as an argument to modify number. Number is a value type. So when we are calling modify number, it's going to create a new variable in the memory with exactly the same value. And this new variable will be passed with the value of 10 to the modifier number, which is not exactly the previous variable. It's something new in the memory. That's why when here we are changing the value to 20, actually the new variable will be changed to 20. And when I write it here, the value is 20. But when the compiler run this method, after running this method, it's going to clear all these spaces from the memory. After returning back to main application at line 7, when it's going to print the number variable, this variable is actually our first variable, which has been untouched. So that's why it's still 10. So call by value means a copy of variable is sent to memory. Any changes made to variable inside the method won't affect the original variable. Now let me change the modify number method and add a ref keyword. By adding ref keyword, I'm actually passing through the variable address to this method. Let me draw the memory structure. Here at top, as you know, we have a number variable, and it's going to occupy a space in the stack with the value of 10. Now this time, because I have the ref keyword to the modified number, when I'm going to pass through this variable, the address of the number variable will be passed through because of the ref keyword. So the actual data will be passed through. Number 10 will be go through, and when I replace it by 20, the actual data will be replaced. 10 will be changed to 20, and this time when I'm going to write it, it would be 20 instead of 10. Let me show you another example. In this example, as you can see here, I have a class name person. I have initialized it with the ID and name. I'm trying to write the name, and I have another method called change name. Let me draw the memory structure again. At top we have stack, at bottom we have heap. And in the first place, when we initialize our class, in the stack we are going to hold the address, and in the heap we are actually going to store the class properties. At the top, we have the ID is a value type, so we're going to store the actual data there. But the second one is a reference type, so we are going to store the address here and the actual data somewhere else in the heap. And here, at first, we are going to write the person name. In the first place, it is Mo, and then we are passing through the person to change method. It's a reference type, so when we are passing through the person, its actual data will be passed through to change name method. And when I replace the name Mo with John, John will be replaced by Mo, and that's why we can see the John here. Lastly, let's discuss class method, static methods versus instance method. Consider we have two classes. In the first one, we have a method which returns an integer value. And in the second one, we have a static method which returns integer value. But what are the differences between these two classes? The differences is in the memory structure. In the first one, we have a class whose address is stored in the stack. and its value in the heap. And in the metadata of this class, we can store method information. It is something like this. At top, we have a metadata information, and at bottom we store the property. And in the metadata, we store the class method location. It is somewhere in the heap. It is something like this. It's pointing to somewhere in the heap. So method is here. Instance methods are associated with an instance of a class. Each object created from the class has its own copy of the instance method. For example, if you create another instance, it would be allocated somewhere else in the memory with its own set of instance method, completely isolated from each other. For instance, as you can see here, I have two separate instances of a class with their own spaces in the memory, completely isolated from each other. But on the other hand, static methods means they belong to the class itself rather than any object instance. When we make something like a method or class static, it means that we need to call it frequently. Therefore, this static method will be stored in a place called high frequency heap at the bottom of the heap. In the high frequency heap, we have the class and its method is stored in the metadata. Actually, that's why they say be careful about using the static methods in the multi-thread environment. For instance, here we have two threads, thread 1 and 2. But in the static class, all these threads have access to the same instance of the class simultaneously. But in the instance method, each thread has access to its own space and allocation, so it's completely safe to use it. But in the static method, because the resource could be shared between threads, it could be really dangerous. So be careful about using it. Understanding these concepts is vital for writing efficient and effective C# code. Thanks for watching. If you enjoyed this video, don't forget to like, share, and subscribe for more coding tips and tutorials. Until next time, keep coding and keep creating. Bye.